Hi everyone, welcome to my Phys2212 lab2 report. I will discuss lines of charge for the U-tape experiment in lab 1. And here's a brief introduction of my lab2 report. I will talk about key concepts and principles in this lab, and then I will do a brief lab 1 recap, and then I will talk about the models and coding part in my web Python. At the end, I will talk about my lab result and the follow-up questions. So for the principles and the formulas we apply in this lab, we know that for the electric field on a uniformly distributed rod or line charge, dE is equal to k times dq divided by r squared times r hat. And then for the total electric field, we'll just integrate this dE formula. We also use second law and third law in this lab. F equal to ma can bring us the gravitational force on tap equal to electric force on top tape, so that we can get our estimated total charge on top tape. And for the constants and variables we used in this lab, they're basically similar to the lab 1 report. However, there's a huge difference here because in this lab we were treating two tapes as uniformly distributed line charge instead of point charge. So that there will be a huge difference in the estimated net charge on each tape, and I will discuss it more in the final result. However, for the other data, we are like U-tape length and U-tape mass, they are basically same to lab 1. And for the models and coding part in my web Python, I defined define a model for two tapes, and here I set n is equal to 70, which means that there are 70 small charge along the line charge along the tape, and they contribute to charge is equal to q in total. And we also have a e-field function, and I inherited the formula in lab 0 to this function, and we also have a model for line charge. And at the end, we will integrate the dE to E using two for loops. So basically here we're iterating through all the charges along the line, along the top tape, and then summing up dE times dQ to get our summed up total electric force on top tape, and we set it equal to the gravitational force on top tape, and then we will get the estimated total charge on each tape. And here's the result of my experiment. You can see that there are two errors on my top tape, and they are basically in equal magnitude or scalar, which means that the electric force on top tape is equal to gravitational force on top tape in magnitude. And for the results and assumptions, in previous labs, the point charge model tells us the top tape on each tape there are estimate 1.4474 times 10 to the minus 8 estimate charges in total. However, for this line charge model, the estimated total charge on top tape is equal to 2.9824 times 10 to the power minus 8. So there's a huge difference. For the assumptions, we are ignoring a resistance on a moving object. I'm also assuming that each U-tape I made had about the same amount of charge evenly distributed along the length of the tape. And for the follow-up questions, I already examined that. I already said that there's a huge difference in the estimated total charge on each tape for these two models, and I will say line charge will be more accurate and more closer to the real value because we are taking into account the length of tape, and it is more realistic to the real world examples because charges will not concentrated on the same point, but they will distributed along the line of charge. And that's it. Thank you for watching.